Hey guys, this is Andrew. This is a quick rundown of my one-line diagrams for the NESC and NEC. This is my NEC that you're looking at here. You have all the rating information for each component. Normally they'd be in boxes next to the components on the one line, but I'm putting them over here on the side. It's good enough for this project. All the sizing I still need to redo because I didn't quite add up all my loads correctly. So I need to size based on the all the load currents added up for each panel for all the phases. And yeah, so you get the size of your grounding, you get the size of your conduit, get the size of the panel boards, and these currents that go on the panel board are not the rated max current for each panel board. It's the actual current you calculate. So that's what goes there. I'm not sure if you need to put the rating of the switchboard because I'm not really sure if it's part of our system. You could probably start your one line here and just have a blank box that says utility, but I just put it on there. So yeah, got all the information I think I need to have on this section. These are the panel boards I found. I'm sure a lot of people are using the same ones. So for any SC, you can see I used the actual, I just took a snip of the section that we're doing, which is the Brasada to Harney, and assuming 100 megawatts. We know, well, actually, we know from looking at the PRD that that's what Brasada is at. It's the 115. And then I assume that everything else here is all at that voltage because they get converted to that voltage to get to this line. So they're all at 115, and the current, I just did the apparent power divided by the voltage to get the current for all of them. So I'm not sure if that's right, but I'm pretty sure it is. The legend is showing all the different switch types, and I used 5 total different kinds of switches, or different combinations of parts rather. So I use a bare switch anytime it was less than 1 mile. I use load switches for like this section right here, this section right here, because these are all a 50-mile stretch. And I put 2 of them here. You really only need to have 1 on this line, but I put 2 of them to keep it, even more safe. And these are the only 2 loops that I used on this smaller section here. And the only times I chose an E, which is rated for 2,000 amps, was coming out of the biggest generation, this 100 megawatts. And Harney was just assumed to be 100 because we weren't given that, but I just said it that. It's an assumption I can make. So yeah, so those are the only E's I use, are just right on the outside. And I have these 4 different taps. I'm not sure if I need to have those labeled. I might even take those off. But if you look at my load schedule, I have a load for each of these 5 different. The load schedules for this one are just that build a switch Excel sheet. So different 5 of them, one for each different combination, to show this is exactly what the switch is built out of. And then also on the bill of materials, I just have the quantity of how many there are. So like each E, there's only 1 of them. And then I think there's 6 of this normal bare switch. So yeah, putting the conductor, you're given that. You just have to look at the SAG instructions, and it says your grounding in line are all of this conductor type, and here's its max rating, which is below the fault current, fault duty amps that's on the PRD. So some of us thought that was pretty interesting. But anyway, here's all the information. You don't have to do it how I did it. You probably did it better, but this is what I got. So thank you.